Here we have a chart. It says opinions of residents in a town and surrounding area about having a racetrack is tabled here. A reporter randomly selects one of these 9,081 people. In other words, if you add up all these numbers, you get 9,081. The question is, what is the probability that the person is for the track? If you pick one at random, so this would be like a 9,081 card deck of cards, and you're picking one card out. A person could be like a card. You sort of think in analogies. If you know how to do something with one thing, if you can make an analogy with the new problem, you can see that the same strategy will work. The basic probability principle says that the probability that the person randomly selected supports the track is just the total number of people supporting the track divided by the total number in the entire group. Well, we know that the column headed support tells us the number of people that support it, so all we have to do is add 3,325 and 4,747. The total number of people whose opinions were requested is the sum of these four numbers, but you really don't have to add them because they told you that it was 9,081. So that's the denominator of the calculation, and 3,325 plus 4,747 is 8,072, so you end up with 8,072 over 9,081. We're back to the same thing as before. They did not ask us to give it as a decimal, so we've got to say, well, that means they want it to be a fraction that's completely reduced. Those two numbers aren't extremely big, and I'm not working with cards. I don't have any numbers in my head to try. So whenever that happens, I just start factoring. And I'm not going through in this as much detail, but you do need to practice. I noticed that 8,072 is an even number, so I know that it'll divide by 2. So it's 2 times something. And when I got that result, the result was another even number, so it divided by 2 again. And then when I got that result, there was another even number resulting, so I got another 2, and when I finished factoring a 2 out 3 times, I was left with 1,009. And what I'd like for you to do is take your calculator and try that. Take 8,072 and divide by 2. What'll be in that display is even. It'll divide by 2 again, so divide it by 2 again. You'll get another number in the display that's divisible by 2, so do it again. When you divided that result 3 times by 2, you'll end up with 1,009. So that tells you that you factored this into 2 times 2 times 2 times 1,009. Now I'm not quite sure if 1,009 is factorable or not, but maybe I won't have to deal with it. So I'm going to leave the numerator alone now and then move to the denominator and do the same thing. I notice that 9,081 is not even, so it will not divide by 2. So I'll move up and try by 3. When you're just trying and you don't know what divides, you start with your prime numbers, 2, 3, 5, 7, and so on, go up through your primes. So I know 2 won't work, so I'll try 3. It turns out that it works. When I divide 9,081 by 3, I get a number that divides by 3 again. If something works once, you check to see if it works again. It turns out that the 3 works twice. When you divide 9,081 by 3 and then divide that result by 3 again, you actually end up with 1,009 again. Well, at this point, it doesn't matter if you can factor 1,009 again or not, because what has happened is the 1,009 is in the numerator and denominator both, so you can just divide it out. So what you end up with is 8/9, which is completely reduced. Please take some time to practice reducing these fractions. When the fractions have really large numerator and denominators and they deal with things like cards, I gave you a strategy. When the numbers aren't quite so big, I gave you a strategy like here, which is just start factoring with your primes. It's tedious, or it can be, but if you want to get the problem completely correct, you have to go through the tedium. Practice makes perfect here. Sticking with this same problem, a second question is, what are the odds against the person supporting the track? Now, we've dealt with the odds enough now that this should be fairly straightforward. If I say that the odds of an event are A to B against, The A, the left number, is the against number, and the B, which is the right number, is the in favor of number. Well, how does that relate here? I've already been given a probability. But remember, we also talked about the relationship between odds and probability, and this is what tells us. It says if the odds against an event are A to B, then the probability of the event is B over A plus B. So what you have is the in favor number goes up in the numerator, but it also appears in the denominator. And then A plus B has to add up to whatever the denominator is. So if you take this and compare it to the answer we got in the first part, what you see is that the B is like the 8. So I wrote the 8 here. The denominator is a sum. They gave it to us as a 9, but then that 8 also reappears down here, and I have to make the numbers add to 9. So if I have an 8 here, and I know I need to get a 9 as a result, that tells me immediately that that has to be a 1. So looking back at that now, I can see what everything is. I know that the B appears here and here, and the other thing is the A. So the A is 1. Well, once I know what A and B are, I can write the odds against that as A colon B. That would be 1 colon 8. The A was 1. The B was 8. And I hope you'll pay attention to this, how you can change from odds to probability and probability to odds. The denominator in a probability is always the sum of A and B. You're going to add A and B to get the denominator in a probability. And one of the numbers, A or B, will be the numerator in the probability. It just depends on the problem, because this is always the in favor number up top. But whether it's the left number or right number depends on whether the odds was given as against or for. If the odd was given as an against, it will be the number on the right of the colon. And if it's the for, the in favor number, it will be reversed. But once you've got those notions, going back and forth between odds and probability shouldn't be that big of a deal.